Board. Okay, I'm going to go ahead and share my screen. And just feel free at any point, if you have a question, to turn on your audio and ask. I'm going to first go over a little bit about the course itself, in addition to who I am and how to access all the material. So my name's Dana, and I work for a company called the Data Incubator. I sent you out a link to our shared Google Drive, and in that drive, you'll see a document called syllabus. So I'm going to walk you all through the syllabus before we go ahead and get started with today's lecture. So my email address is at the top of the page. You can feel free to contact me anytime at dana@thedataincubator.com. And the title of this course is Data Manipulation and Cleaning in Python. And the goals that I have for you, what I want you to get out of this course, is how to use Python to do some basic data cleaning and getting your data in a format that you can use for whatever purposes that you have. So hopefully you have taken a look at the Codecademy tutorial if you're new to Python. So I will briefly touch on some of the things that are covered there. We'll do a review as we go through the material. But if you haven't done so, please go ahead and go through that tutorial. It's a really good one. It's interactive, and I think it's a great introduction to Python. In addition to Python, we'll also be touching on SQL or SQL, and Codecademy also has a great tutorial on SQL. So again, if you haven't done so, take a look at the Codecademy SQL tutorial. So lecture will happen at 4:00 p.m. Eastern Standard Time, and it'll run approximately an hour and a half. Immediately following lecture, we'll have a 30-minute office hour session, in which time we'll go over the assignments, and you can feel free to ask any questions that weren't addressed during lecture. So this course will run for 2 weeks. In the first week, we'll be covering object-oriented programming, what are classes and objects. That will be today's lecture. We will also take a deeper dive into functions, iterators, generators, and coroutines. And then for the second half of the week, we'll be focusing on how to extract data or get data from the web. So we'll talk about strings in Python and how to access data using APIs, a website API, and how to scrape websites to get data. Next week, we'll be talking about how to organize your data using some Python libraries like Pandas and NumPy. In addition to plotting data, we'll talk about Matplotlib. But we'll also then talk about SQL, how to use SQL to do some data analysis. All right, and finally, we'll talk about debugging. That's what exceptions is all about. And we'll wrap up with how to, some good engineering practice when it comes to writing code in Python. All right, so since you have successfully joined lecture, you have made it onto GoToMeeting with the correct meeting ID. I will update the syllabus as soon as I record lecture and post it on YouTube, and I will post the link also in the syllabus. So in addition to joining in these virtual lectures, you should have access to the lecture content. How do you access that material? Well, you're going to go ahead and click on this link, https://army.thedataincubator.co/hub/login. A couple days ago, I emailed you a password. So you'll be prompted once you click on this link to enter your email address. So the email address which I sent your password to is the email address you'll use to log in. And make sure that you can access that. Make sure your password works. If not, please let me know. All right, so let's actually take a look at what you'll see once you log into what we're calling Jupyter Hub. So as soon as you type in your username and password, you should see a screen like this. If you click on the folder titled Data Course, you'll notice that inside of Data Course, there are two subfolders. There's one titled Data Wrangling and another titled Intro to Data Wrangling. For today's lecture, we'll start off by going over some content in the Intro to Data Wrangling folder. So please go ahead and click on that. And now what you'll see is, in addition to more folders, you'll see these files which end in IPYNB, which stands for IPython Notebook. So let's go ahead and click on the notebook titled IW_classes. That will be the first lecture we'll be going over. If you click on that, you'll get directed to a new window, and you'll see some code in some cells, in addition to some markdown text. So what's nice about these notebooks is you can execute Python code inside of these notebooks. And as I give lecture, feel free to go along with the content and execute code as I do. So how do you execute code? Well, let's take this first cell. There's a couple ways of doing it. You'll see in this toolbar up top, this tab called Cell. If you click on it, you could run cells. There's a shortcut. If you take a look at below this toolbar, you'll see some icons. You could hit the Run button as well, and that will run a cell. Notice when you run a cell, what happens. On the left-hand side of the cell, you'll see something called your line number. Once a cell executes, inside of these brackets, you'll see a number. Since this is the first cell that we've run, that number is 1. If I want to execute the next cell, I could go ahead and click that button again, Run. But there's a nice shortcut that I like to use. And on my keyboard, that's Shift and Return. So if I want to run the next cell, I'm going to go ahead and hit Shift Return. And now what do I notice? Inside those empty brackets, I see a 2, which means I successfully ran that cell. So this is something nice to keep track of. All right. So that's a brief overview of how to execute Python code inside of a Jupyter Notebook. So as we go along, I will give you a little bit more information how to work inside of these notebooks. But let's go back to the syllabus. All right, so this is the what's known as Jupyter Hub. What we just went over is where the material for the course lives. But let's talk a little bit about what assignments I'll be asking you to do. If you take a look inside of our shared folder, there's going to be a document called Coding Challenges. I've also provided a link to that document inside of the syllabus. So if you go ahead and click on it, what will you notice? Well, each day I have assigned a certain problem. For today's class, I want to get you familiar with the interface that we'll use to do these assignments. So I've already posted it, as well as the solution to the first problem. So it's a pretty easy problem if you haven't tried solving it yet. After lecture, go ahead and do so. I will demo how to solve this problem in office hours after lecture. But the solution, if you've already attempted it, is up there and available to you. So for tomorrow, before tomorrow's office hours, so after today's lecture, go ahead and take a look at the challenge for Tuesday. Today we'll be talking about Python classes, and this challenge is going to ask you to build a class in Python. The solutions I will post before every lecture. So before lecture tomorrow, you'll notice if you take another look at this coding challenges document, you'll have a link to the solution. Today I actually wrote the solution out by hand, but in the future, you'll have a nice link and with some explanation about how to go about solving the challenge as well. Okay. So, like I said, immediately following lecture, we'll have office hours, and we will go over the solutions to the challenge problems, and you will also have time to ask any questions that were not covered or answered in lecture. Finally, there's one more document in our shared Google Drive, and that's called Whiteboard. And this is my low-tech way of communicating with all of you. If it's important, an important announcement, I will email everybody. But for example, when we talk about solutions to the coding challenges in office hours, if you have a solution that's different than the reference solution, feel free to post it on Whiteboard. We could share code that way. You could start chats up in Whiteboard, so we can make it whatever really we want it to be. So that's available to you. Right now it's a blank document, but we'll populate it with Python code in the future. Okay. So that's everything on the syllabus. Does anybody have any questions before we start with lecture? Okay. So again, the first topic we'll be covering is classes in Python. So go ahead and inside of your data course, Intro Data Wrangling folder, click on the classes notebook. I have gone ahead and run the first two cells, and if you haven't done so, please do so now. Again, by either clicking the Run button, or cell Run Cells, or Shift Return. What these two cells are doing is we're importing some packages that we'll be using throughout lecture. So in the first cell, this deals with some plotting packages. So this enables us to plot things inside of the Jupyter Notebook, inside of our Jupyter Notebooks. And the second thing that we're importing, the second package, is something that we at the Data Incubator wrote. And we'll see it later on, and I'll explain what it does once we get there. Well, let's first start talking about what is object-oriented programming. Well, to understand what object-oriented programming is all about, there's two main concepts that are core to this idea of object-oriented programming. And those two things are classes and objects. So before we talk about what objects and classes are at low level, let's talk about them at a very high level. And I'm going to do so by giving you an analogy. So if you are interested in cooking something, like a cake or some stir fry, you might follow a recipe that tells you how to do so. In the Python world, classes you can think of as recipes for making a certain object. So it's basically like a template or a set of instructions for creating something which we're calling an object. So in our analogy with cooking, the objects are going to be the cake that you actually end up making or the stir fry that you actually make. And that is a result of following a class's recipe. So let's give you an example of this. If you went through the tutorial, you should be familiar or have seen these things called dictionaries and lists in Python. So dictionaries and lists are some built-in classes to Python. Later on in the notebook, we're going to create our own classes or our own templates or recipes, but there are certain structures available to us in Python where we don't have to write it out, these templates out in a lot of detail. So what are dictionaries and what are lists? Well, dictionaries, if you remember, they consist of these key value pairs. And we've created two instances of this dictionary class in the cell below. So the key value pairs are separated by commas. The keys are going to be, if we take a look at the first key value pair, everything to the left of this colon and everything to the right of the colon is going to be the value associated with that key. So what does this allow us to do? If we have a dictionary, we can look up some values associated with a key. In this first example, we might have some record of some animals that live inside of a person's house. So this dictionary could correspond to, in our home, how many cats, dogs, and humans do we have? Well, there's 3 humans, 2 dogs, and 1 cat. So we can create keys in our dictionary using strings, as we did in this first example. But keys can also be integers, like in the second example. So dictionaries, you could think of it as having, being very similar to an actual dictionary that we use in English. So if we want to, say, look up inside of a real or a dictionary, the book, the definition of a word, the word in this analogy is going to be our key, and the definition is going to be the value. What we can't do is we can't look up a key or a word given a certain value or definition. Some other important properties of dictionaries is that they're unordered. However, if we want to store data in some sort of structure where we care about order, we could use something like a list. And here we have 2 instances of a list class written below. The first is a list of integers, and the second is going to be a list of strings. So let me go ahead and run the cell. And what I'm going to do is I'm going to insert a cell below, a blank cell, and I'm going to write some code for you. How I'm going to do that is I'm going to go to the Insert tab and click Insert Cell Below. And I'm going to go ahead and print out list 1 after I created it. And what we'll see is we can return this list that we created to us by just printing it out. And what do we notice? Well, this is exactly what we've, the order is preserved. We start with a 0, and the next element in our list is 80, 20, 60, so on and so forth. But let's actually print out our second dictionary that we created. Oh, this is a bad example. Let me create a new dictionary. Dictionary 3. Let's do 4, 3, 1, 5, 10, 1, and print that out. Well, notice I created a new dictionary called Dict3 with 3 key value pairs. And when I print it out, notice that the order is not preserved. So that's an important property or characteristic of dictionaries. So the dictionary and list classes in Python have different functions associated with it. Much in the same way, if we were going to follow a recipe for cakes versus stir fry, the flavor profiles of what we create are going to be different from each other. Okay. So now that we created these dictionaries and lists, let's verify that they belong to the dictionary and list Python classes. And how do we do that? Well, let's use the type function, which takes as an argument the objects that we created, and it's going to return their type or their class. So if I go ahead and run the cell, what do I get? Well, we see that the dictionaries, these dict1 and dict2, are types dictionary, and list1 and list2 are types lists. So that's good, that makes a lot of sense. So these objects, dict1 and dict2, list1 and list2, are instances of the class dictionary and list. These objects exist in different locations in memory, and if we want to inspect where they live in memory, we can use the ID function. So let's go ahead and run this cell, and we'll see that these locations are all unique because they are different objects. Okay. So objects that belong to the dictionary class and objects that belong to the list class have different properties. So dictionaries, like I said, have key value pairs. And if we want to inspect the keys in dictionary 1 and dictionary 2, we could use this using this notation, where we call this dot keys on dictionary and dictionary 1 and 2. And lists, what we could do with lists, since order matters, if we care where 70 or bread exists in list 1 and list 2, we can call this index, what's known as index method, to find out where 70 and bread lie in our list. So let's go ahead and do that. So the keys we see with dictionary 1 and dictionary 2 are dog, human, and cat, and then 1, 2, 3, and 4. And then what we see for lists is that 70 exists in position 7, and bread exists in position 3 in list 2. Something important to know, let's take a look at list 2 and see if this makes sense. Let's count the number of elements where bread is. All right. Well, that's weird. Bread is the 4th element of the list. Why is it giving me a 3? Well, something important to remember when we're working in Python is that indexing starts as 0. So milk is actually at position 0, eggs is in position 1, cheese is in position 2, and bread is in position 3. So that's something to keep in mind. Well, I'm going to go ahead and insert another cell by going insert cell below. And let's say I want to see what position dog is in my dictionary, or dictionary 1. So let me try to do dict1.index dog and run this by doing shift return, and I get an error. Well, that's because the dictionaries and lists have different properties, and finding the index of the dog key doesn't make any sense. So that's something to keep in mind. So anything that belongs to the same class has similar types of behaviors. We just saw that for dictionary 1 and dictionary 2, we can inspect the keys, but we can't, well, if we try to inspect keys for list 1 and list 2, that wouldn't really work because they have different properties because they belong to different classes. So let's talk a little bit more about what objects are in Python before we move on to how do we create our own classes. So objects are these mysterious things we talked about that exist in memory somewhere. But what do they really consist of? They're going to consist of some sort of data, which we're going to call attributes, and some functions associated with that data that we could apply on that data called methods. And if you're not familiar with object-oriented programming, that might seem a little bit odd that we're clumping things together in this way, but think about why that might be useful. If you're going ahead and writing code in this modular way, we're clumping together data and functions associated with that data or that you can apply on that data. It cleans up your code and makes it a little bit more readable, and it's easier to work with. So that's why we're going to go ahead and do that. So again, the data associated with objects have a special name, and they're called attributes. And these functions that we apply on them are called methods. So let's take a closer look at the objects we created above. In particular, let's take a look at list 1. We saw that we could inspect where elements in our list lie using the index method. But now let's consider another method available to us. So lists have a method called sort. So let's take a look at what list 1 is again. This is going to be the list of integers 0, 80, 20. And what do you think will happen if we apply this method called sort on our list and then print out list 1 again? Well, what do you see? This the second element, or the element associated with index number 1, has changed from 80 to 10, and now our list is sorted in ascending order. Notice now that we've fundamentally changed our object because this is now permanently sorted. We've sorted everything in place. But there's another way to sort elements in a list. So let's take a look at list 2, since we've already sorted list 1. So list 2, recall, is the list of strings. So we have milk, egg, cheese, and bread. What do you think will happen if we sort it? These are not numbers, so how is it going to sort? Well, it's going to do this alphabetically. So what do we expect to appear first in our sorted list? Well, we expect to see bread first. But now let's not apply a method that belongs to the list class on that list. Instead, let's use a function. We're going to use Python's built-in function called sorted and pass the argument list2 into that function. Let's go ahead and print the output of this function. And then let's go ahead and print list2. And what do we notice? Well, on the first line, the output of the sorted function is going to be list2 in a sorted manner: bread, cheese, eggs, milk, alphabetically. But notice that passing list2 into the sorted function did not change the order of the elements in list2. We see that when we then print out list2, we still have it in that original order: milk, eggs, cheese, and bread. Unlike if we call the sorted method, which would change the data contained in list2 to permanently sort it. So that's something to keep in mind. When you're working with methods, if you have a method like sort, it's going to apply that method on that data and change some of that object. Whereas this function that we use, which does not belong to that list class, did not change our object. Okay. So lists and dictionaries, again, are these built-in Python classes, but how do we go about creating our own class? Well, we're going to use this class keyword followed by the name we want to give our class. In this case, let's create a class called rectangle. It's pretty standard whenever you create a class that you want to capitalize the first letter in that name. So let's follow convention and call our class uppercase rectangle. We're then going to follow that class by some parentheses. And inside, we're going to put this object. We're going to pass an object to our class. And we're not going to worry too much about it now. We'll come back to it later in the notebook. But this object, in previous versions of Python, you didn't have to do this, but Python sort of changed something about the objects. They've changed some of the fundamental methods and attributes associated with each object and how operations are implemented. So in this new version of the class, we're going to use this object, send the object in as an argument. We're then going to follow it up by a colon. And something that's really important when we're working with Python is that white spaces matter. So anything that we want to write inside of our class is going to be on subsequent lines, and it's going to be tabbed in. So that white space here is very important. And right now we're just creating a very simple dummy class that doesn't really do anything. So we're just going to use this dummy keyword pass just to follow this convention of tabbing things in. So let's go ahead and run it. And I'm going to also jump over to another notebook very briefly, just because we'll be talking about functions and methods in a second. So if you could go back to your intro data wrangling directory and scroll down until you find IW_functions, let's compare this notation, how we create classes, to how we create functions. So hopefully this should be a review. If you're a little uncomfortable with this, take another look at the Codecademy tutorial to go over how you create classes and functions in Python. But I'm going to go ahead and run the first cell in this functions notebook, and let's compare how we created a class to how we create a function. So for classes, we use the keyword class to tell Python we are creating a class. If you're going to create a function, we're going to use the def keyword. We're going to follow that def keyword with the name of our function. In this case, we're going to create a function called subtract. And unlike classes, by convention, we'll give functions lowercase names. So lowercase subtract. Following the name of our function, we're going to use these curved parentheses and specify that we want two inputs into our function, A and B. Once we do that, we're going to follow it up with a colon, and anything that belongs to our function, we're going to tab in. So again, white space matters when we write functions as well as when we write classes. So here's the heart of our function. This is a little bit silly, but we're going to take A and B, the inputs to our subtract function. We're going to subtract B from A, call the difference diff, and we have to use this return keyword to return diff from our function. So whenever we call that function, what's going to get returned to the user is going to be whatever follows this return keyword, or in this case, A minus B. All right, now that we created our function subtract, we can go ahead and use that function or call that function. In this case, if we want to know what 5 minus 3 is, we can write out subtract parentheses 5 comma 3. And what do we expect to see in return when we run that line? Well, that difference, which is going to be 2. All right, so we'll come back to this functions notebook probably tomorrow. We'll see how far we get with classes today. But I just wanted to go over that because we'll be writing some functions into our classes. All right. So we created, going back to the class notebook, a class called rectangle. That doesn't really do anything. But what is rectangle? We can call the type function on rectangle. And what do we expect to see in return? Well, remember, okay, is rectangle an object or a class? When did we use type before in this notebook? Well, we used it when we want to check what class dict1, dict2, list1, and list2 belong to. But what will happen, do you think, when we call type on a class? Let's go ahead and run that cell, and we see that rectangle is going to be a type. So type of rectangle is type. Interesting. What about this first part of this line that we ran? Rectangle, if we just call rectangle, what we'll see is that here's some notation that we'll come back to. All this is saying is that our rectangle class exists in what this what's known as the main part of our script. So whenever we're running everything at the sort of top level code in whatever we're running in Python, that top level code is going to exist inside of this main namespace. And we'll come back to this when we talk about functions. This will hopefully make a little bit more sense. So if that didn't really resonate with you now, hold tight, we'll come back to this idea a little bit later. Okay, now that we created this rectangle class, how do we create an object that is an instance of the rectangle class? Well, if we're not using our built-in Python dictionaries and lists, what we're going to do is we're just going to give our object a name. By convention, we're going to give it some lowercase name. We'll call it lowercase rect, and we'll set it equal to the rectangle class. And notice that we're going to include these parentheses. So rectangle followed by some empty open parentheses. Let's run that cell. And now if we run rect, what do we get? Well, we see that is an instance of this rectangle class. But unlike the time when we ran just rectangle, we'll see that is an actual object that exists in a certain place in our memory. So how do we verify that rect is indeed an instance of rectangle? Well, we could do this two ways. We can call type on that object and see if the type is equal to rectangle. Or we could use this function called isInstance, which takes as input an object and some type or class. And if we run this cell, what do we expect to see? Well, is rectangle a type, or is rect a type of rectangle? Well, that is a true statement. And is rect an instance of rectangle? That is also true. So we get trues printed out. Okay. So let's go ahead and create a couple more instances of this rectangle class. We'll call these objects rect2 and rect3. So let's go ahead and run this code. And now my question is, well, rect2, rect3, and rect, they're all pretty much the same. They're identical, but are they different objects? Well, one way to sort of verify this is let's see if they exist in different parts of our memory. We'll see what addresses they live in. So we're going to print out the IDs of these three objects and see if they are the same or different. Well, they're different, so we have in fact created three unique objects that live in different locations in memory. Okay. Well, this rectangle class that we created doesn't really do anything. It's kind of boring. And as we talked about, objects have these things called attributes, which is data that's associated with that object, and methods, which are functions that we could apply on the data in our object. So let's go ahead and add some attributes and methods to our objects. So let's first talk about attributes. How do we add or access the attributes of an object? Well, we can use the syntax where we specify the name of our object, followed by a period, and then followed by the name of the attribute that we either want to add or access. So let's see an example of this. Let's take our rect object, and this doesn't make a lot of sense, but let's give it an attribute called banana, and we'll say that banana is equal to 5. So our rectangle is now going to have 5 bananas. So how do we give our rectangle 5 bananas? We're going to type out rect, followed by a period, followed by a banana, followed by an equal sign, and we're going to set it equal to 5. Once we've done that, we could say, okay, well, rectangle, how many bananas do you have? Let's print that out. That's going to be in line 2 in the cell. So let's go ahead and then print out rect.banana. What do you expect to see? Well, we expect to see 5 because we just gave our rectangle 5 bananas. Okay, well, that's great. Let's inspect how many bananas our second rectangle, rectangle 2, has. Well, what do you think will happen if I run this cell? I gave the first rectangle 5 bananas, but how many bananas does rectangle 2 have? Well, we get an error because banana is not actually an attribute of rectangle 2. We only added it to rectangle 1, or the first rectangle. Here we're using this expect exception function that we've seen earlier that we imported in the second cell in our notebook. So all this is doing is it's saying, okay, we expect an error to arise. So if I were to go ahead and run all the cells in my notebook, the code wouldn't just stop running. And that's all it's doing. So we see we get an error because our second rectangle doesn't have a banana. Well, instead of just adding attributes to objects like this in a per object basis, what would make more sense is let's, in our recipe or a template, or in our definition of our class, let's go ahead and say, okay, we expect rectangles to have certain types of attributes. So let's go ahead and do that. So every time we create an instance of the rectangle class, it will have some attributes associated with it. So we don't have to add them in one by one. All right, so let's take a look at this next cell. Here we're going to call, we're going to create a new class, also named rectangle, in the same way we did above, but instead of putting a pass, we're going to add some functions inside of our class. Okay, well, the functions associated with a class are methods. So instead of calling these functions, even though they look like functions and act like functions, I'm going to start calling them methods. And what do you notice? Let's take a look at the first method called init with these double underscores. Well, what's happening inside of init? Well, it takes as some argument something called self, something called width, and something called height. And what is it doing? It's taking these arguments, width and height, and adding them to this object self using the self.attribute syntax. So width and height now inside of this method are going to become attributes of whatever self is. Interesting. All right, well, let's take a look at the second method called area. What's happening in area? Well, it takes an argument called self. And what's it doing inside of this function? Well, it's calling the attributes width and height, which we created in the init method, and it's multiplying them together to compute area. Okay, so taking a look at this code, width and height are going to be the attributes of the rectangle class, and we also have associated with the class a method called area. So let's go ahead and run it. I'm going to talk about self in a little bit more detail in a second, but let's first talk about methods. We saw that we could create attributes by using this object.attribute syntax. Well, if we want to access methods, or maybe even create methods, we're going to use this object.method syntax, where the difference is that the method is going to be followed by these smooth parentheses, which indicate that a method is a function and expects maybe some arguments. Okay, let's create an instance of this new rectangle class. We're going to call it rect, as we did before. And what are we doing different here? Originally, we didn't actually pass any arguments into the rectangle class, but in this case, we're passing in two arguments, 3 and 5. So what's going on when we create an instance of the rectangle class? Well, what we're really doing is we're calling this init method. It's a very special method that usually you're going to write whenever you write any class. And, well, that's weird. This init method takes in 3 arguments, but when we create an instance of the rectangle class, we're automatically calling this init method, but we're only passing in 2 arguments. And why is that? Well, that self is understood. So what is self? Self is going to be the object itself. So 3 and 5 are really going to correspond to the second and third arguments, width and height. So I'm creating an instance of the rectangle class, and as I do so, when I call this init method, I'm going to store 3 to the width attribute and 5 to the height attribute. Now let's call a method of the object using the object.method syntax. So let's call the area. We're going to compute some area. What is it going to return? Well, it's going to return the product of the width times the height. So let's go ahead and run this code. And what do we expect to see? Well, we're getting returned 15, which is indeed 3 times 5. So self is actually not a keyword, but it's a convention, much like how you capitalize the name of classes and use lowercase letters to call functions, or name functions, I should say. So you could, in theory, just call self anything you wanted, like my object, and it would work. But what self is doing, it's really important that we include it whenever we create classes, or methods inside of classes, because that object, self, is going to be passed from method to method inside of that class. Remember that the methods act on the object, so they're going to, in a sense, be acting on themselves, and you need to therefore specify that. So what's really going on under the hood when you call some object.method, and maybe that method has some sort of argument? In this case, area didn't have another argument aside from self. Python is changing it to class.method object argument. So we could go ahead and verify this. So let's call rectangle.area and pass it as an argument the object, which is in this case rect. And what do we expect? Well, we hope that it's going to return the same thing as we saw in the line before. And that is indeed the case. We get 15 as a result. So this is a common mistake to forget the self argument. And here, if we create a class below, and we forget to say, as an input for the second method area, we forget to pass self, we will get an error that looks like this. Area takes no arguments, but one is given if we call that method later on. All right, so just as a side note, this init method, the double underscores means that this method is special. And you could think of it as sort of an initializer function. And as you go along in your Python careers, you'll notice that there's other double underscore methods and double underscored attributes sort of available to you. And these are just going to be special methods or attributes. In this case, this init one has a special function, and it's going to be run every time you create an instance of a class. Okay, now let's take another look at this rectangle object. We gave it, when we created an instance of it, we initially specified that its width was 3, but there's nothing stopping us from accessing that attribute width and going ahead and changing it. So let's change it using the syntax object.attribute, and instead of having it be 3, let's give it a value of 2, and then go ahead and compute the area of this rectangle. So what do we expect? Well, now if width is 2, the area is going to be 2 times 5, which is 10. Let's do another example of Python classes, and we'll talk about some convention when it comes to naming attributes and methods inside of that class. So let's create a class called person. We're going to pass it this object argument, as we did before. We're using a capital P for the name of our class, and we're following it up with a colon. We're going to tab in everything that belongs inside this class. And inside of our methods, we're also going to, again, tab in anything that belongs to these methods. So let's create a person where when we create an instance of this class, we're going to initialize this person with a first name, last name, and age. But when we go ahead and save first name, last name, and age to our class, we're going to name these attributes starting with a single underscore. And when attributes or methods begin with a single underscore, what that's telling you is you're not, as a user, supposed to be accessing them. They're used internally within that class, but there again is nothing stopping you from accessing them. So let's continue, and I'll show you what I mean by this. So let's save our attributes, first, last, and age, to our self object. We'll create two other methods. The first one is going to be something that's internal to the person class. We'll call it underscore get underscore full underscore name. It takes as an argument the self object. And what is it going to return? Well, it's going to return a string. And this is some fancy string formatting, which we'll become more familiar with when we go through the strings lecture and start trying to scrape websites. But all this is saying is we're going to create a string where we're going to have two things in our string separated by a comma, and those two things are going to be strings denoted by %s, and they will be replaced with whatever is following this other %. It's again a little bizarre. So in the first %s is going to be replaced with the attribute underscore last, and the second %s is going to be replaced with the attribute underscore first. So what is this function or method returning? It's going to return some formatted name, which is going to be string, last name, comma, first name. We have another method associated with a person class, but that method does not begin with an underscore. It's going to be called getInfo, and it takes as an argument the self object. And what is this going to return? Well, it's also going to return a string. Let's see what's going on here. Well, we see a %s and a %d. Those are going to be replaced with the things that follow this this purple %. The %s is going to be replaced with a string. That string is going to be the attribute, or sort of the result of the method getFullName. And the second %d is going to be replaced with a digit, an integer, which corresponds to the attribute underscore age. So let me go ahead and run it. So I'll create this new person class, and let's create some people or some objects that are instances of this class. Well, how do we do that? When we instantiate this person class, we have to give it a first name, a last name, and an age, because in our init method, we expect those three arguments. All right, so we'll create three people. Person 1 will be named Malcolm Reynolds, age 41. Person 2, Zoe Washburn, age 37, so on and so forth. Okay, now we have three objects, person 1, 2, and 3. And all we really should be trying to do with those objects is calling the getInfo method. And why is that? Well, getInfo does not start with an underscore, so it was meant for us to get info on those people. We were not really supposed to access the getFullName, their age, their last name, their first name, because those things start with an underscore, but we could still do that. So let's go ahead and see that in action. Let's call the getFullName method and the age. So it still works, but here's something interesting. I'm going to insert a new cell below, and there's some autocomplete functionality available to you in these Jupyter notebooks. If I want to type out person 1, and I want to see what attributes or what methods are available to me associated with this object, I can hit the tab, and what I get is the getInfo method. So because of the underscores in getFullName and age, when I do this tab autocomplete, it only lets me autocomplete for the things I'm supposed to be accessing, meaning the getInfo method. All right. I'm going to move on to talk about an important concept associated with Python classes, and that's called class inheritance. I'm going to create a new class called Square, and I'm going to do that using the class keyword, followed by the name of my class, Square, finishing it off with a colon. But what will you notice? Instead of typing an object inside of these parentheses, I'm going to pass in my rectangle class. If I do that, I'm saying that my Square class is going to inherit everything from the rectangle class. And what does that mean? All the methods associated with that class, so the init method and the area method, are going to be accessible to me whenever I create an instance of the Square class. So I don't have to write out the area method again when I created this class, Square. The area method is available to me via class inheritance from rectangle. All right, so I'm going to inherit the init method and the area method. But since squares are not rectangles, I want to do something a little bit different when I create an instance of my Square class. So how are squares different than rectangles? Well, their length and their width and their height are going to be the same. So instead of specifying a width and a height, whenever I create an instance of it, I'm just going to give a single value that corresponds to the length of the square. So what I'm going to do is I'm going to rewrite this init method. What is it going to take as arguments? Well, it's going to take itself, and it's going to take in that single value. However, I'll recall that our area method, let me go ahead and scroll back to where I defined, the rectangle class. Area multiplies the width by the height. Well, so I have to do something when I initialize my square such that the area method still works. So how I'm going to do that, what I'm going to do in my init method such that I could use the method area associated with the rectangle class, well, I'm going to take my length. I'm then going to call the init method associated with the rectangle class, and I'm going to pass into that method self, my object, and then I'm going to say that the width and the height are just going to be equal to the length. So now, if I run that, and if I want to create an instance of Square, Square has a length of 4, and then I want to compute the area, what am I going to get? Well, 4 times 4, which is going to be 16. So that's great, it works out nicely. So rectangle and square have, there are certain types of classes. Rectangle is called a superclass, and square is called, so rectangle is a superclass of the square class, and rectangle is a superclass of the class square, and square is a subclass of the class rectangle. So, something to note, instead of creating the class in the way we did above, where we explicitly wrote out rectangle.init, we could add some flexibility to our code, and we don't have to hard code in the rectangle class inside of our init method. Instead, since we know that rectangle is a superclass of square, we could use Python's built-in super function to access the methods of that superclass. So let's do this. Let's rewrite over the square class using the super function. So instead, in our init method, instead of writing out rectangle dot underscore underscore init underscore underscore self length length, we'll use super, which takes as input the class that we want to find the superclass of, namely square, and the object, that's going to be self, and then just accesses the init method of that superclass. So just another way of writing things. This is the more Pythonic way of doing it. And let's go ahead and create a square that has length 5. Well, before I run the cell, I want you to think about, what do I expect the 4 lines printed out to be? Let's take a look at them and let's see what we expect Python to return. So we're going to use the type and is instance functions that are built into Python to verify whether or not the object square, the type of object, is equal to the class square, and whether or not square is an instance of the class uppercase square. And we'll do this with rectangle as well. Is the type of square rectangle, and is square an instance of rectangle? So I'm going to run this and you'll see why, or the difference between using type and is instance. So in the first case, lowercase square is uppercase square, and square is an instance of square. But what's interesting is that the type of square is square, not rectangle, so that third line is going to be false. However, a square is an instance of the rectangle class, so that fourth line is going to be true. So type, again, corresponds to the class name, and if you want to say whether or not an object is an instance of a class, well, it could be an instance of more than one class, but it could only have one type, as we see here. All right, let's go through another example. We saw that we could create a class that inherits from one class, but we could inherit from multiple classes. So let's do this. Let's go through another example. Let's create a class called hello. And hello, we're going to, as input to the hello class, we'll specify that this hello class is going to be an object, this new Python object. And we're going to give it a method. That method is called speak, and it takes as an argument, aside from itself, some name. That function or method is going to return some printout saying hello, whatever name. So hello Dana, hello whoever. Once you create a hello class, we could create a new class called hello rectangle. This is a little bit silly, but it's going to inherit from our rectangle class in addition to the class we just created called hello. So how do we inherit from multiple classes? Well, inside of these smooth parentheses, we just have to specify which classes we want to inherit from. So rectangle and hello. What we're going to do, we're not going to add any new other methods, so we'll just use the pass dummy variable or dummy keyword. Just so that the syntax is correct, we need to have something tabbed in under our class whenever we create one. So we'll just put a pass there. And now, what functions do we have associated with the hello rectangle class? Well, so everything that's available to us in the rectangle class and the hello class. So when we go ahead and create an instance of hello rectangle, we're going to use the init method associated with the rectangle class. So we have to declare some width and height. So we're going to give our hello rectangle a width of 3 and a height of 5. We can ask that hello rectangle to speak. We could tell it, say, hello Brian, by calling the speak method on an instance of that class or object called hello underscore rectangle. And then we could also compute the area of that rectangle by calling the area method. So let's go ahead and do that. Oops, I forgot to create hello. And so our rectangle says hello Brian, and its area is 15. Okay, well, you might wonder, does the order in which we inherit from classes matter? So to explore this idea, let's go through an example. We'll create 3 classes. We'll create a class A, a class B, and a class C, which inherits from A and B. So these classes are pretty simple. Class A and class B have a method both named function. The method func associated with class A prints out class A, and the func associated with class B prints out class B. Well, what happens if I create a class C that inherits from A and B, and then I call the func method associated with an instance of the class C? Well, there's a conflict between, in this inheritance, well, we have a method called func associated with both A and B. So what will happen when we call that method? Any thoughts? Well, that's interesting. It prints out class A. And that's because A is listed first when we create class C. So A takes priority over B. Okay. So if there's a conflict when it comes to which, if 2 classes that you're inheriting from have the same method, or, well, different methods that are called the same, there's going to be some order called the method resolution order, which specifies which function you're going to pick and choose from. You can inspect that method resolution order by accessing the attribute of class C named underscore underscore MRO underscore underscore. Now, these attributes, remember, as I said, with these double underscores, they're special attributes. I'm going to go ahead and run this line. And what do we see? Well, what takes priority? If we had created a method inside of class C called func, that would take priority over the func in A and B. So this is the order in which priority is taken. And what do you notice? Coming back to this object that we used when we created the rectangle class to begin with, well, let's talk about what's actually going on with this object. Well, by asking, where do you think this MRO attribute comes from? Well, that MRO attribute is inherited from this object class. So there are actually more attributes available to these objects or these classes that we write, and they're inherited from this object class. So that's where MRO comes from. Okay. So let's create a new class. We'll call it C2, but in this case, we're going to inherit first from B and then A. So if we create an instance of C2, we'll call it little c2, and call the func method, what do we expect to print out? Class A or class B? Well, since B is listed before A, we're going to print out class B. Now let's inspect the MRO attribute, and we'll see that the order goes C2, B, A, and then object. Okay, so we could run into problems when we do multiple inheritance. So there's types of classes that we can create that sort of minimize the possibility of running into these conflicts. So let's talk about 2 different types of classes that we generally tend to create in Python. The first one is called a mixin, and that just adds a very small specific capability to any subclass that inherits from that mixin. In this case, in the examples in this notebook, that is, remember we created the hello class that really only had a single method, the speak method. So the hello class is what's known as a mixin, and it just adds a little bit of functionality to the hello rectangle class that we created from it. There's also things called interfaces, and they are classes that define a particular set of methods or even attribute that a subclass is supposed to implement. So how does that work out? If you create a class that inherits from interfaces, an interface class, that interface class will have that method sort of built into it. And if your subclass does not rewrite over that method or implement that method, you're going to get some sort of error. So let's see that in action. Let's expand on the person class that we created above. We're going to copy over our init method, our getFullName method, remembering that we start with an underscore in this method, so it's internal to that class. So other methods in that person class call it, but we as users are not really supposed to call it ourselves. We're going to copy over the getInfo method, and we will add in one more method called report. What is going to be inside the report method? Well, we're going to talk about raising errors later on in week 2, but we're going to specify that if any subclass that inherits from this class does not implement the report method, we're going to raise an error. Okay. So let's create 2 more classes that inherit from this updated person class, and we expect them to have their own report methods. So let me go ahead and run this cell and define 2 subclasses. We'll call one subclass teacher that inherits from person, and we'll call the other class student, which also inherits from person. So let's take a look at what's going on in teacher to start off. We're going to have a new init method. Well, remember, person, we have to create whenever we create an instance of the person class, we specify a first name, a last name, and an age. But since this person is a teacher, when we create an instance of the teacher class, let's also give that object, a teacher, a department. So let's add a department attribute. So in addition to first, last, and age attributes. So how do we do that? Well, let's look at the superclass of teacher, which is person, and use that init method to add first, last, and age attributes to our class. Then let's take this final argument into our init method, department, and add a department attribute. And something else we'll do is we'll create another attribute called students, but that for now is going to be an empty list specified by these square brackets. So we expect our teacher to have students, but when we create a teacher object, we're not going to type out all the students to begin with. We'll use a method called addStudent to add students to this students attribute. So let's go ahead and take a look at that addStudent method. What does it take as input to that method or arguments? Well, the first argument is going to be the self object, and the second is going to be the student that we're adding to our students list. We're going to use the append method of this list being a built-in Python class having its own method, so we'll call the append method on students to just add another student to our ongoing running students list. And we must have a report method. So what's going to go in this report method? We're going to call this getInfo method that's available to us that we inherited from our person class. And we're going to use our department or access our department attribute using this object.attribute syntax. And we'll create a string called the title, which will just give the teacher's name in that formatted last name, comma, first name syntax, followed by his or her age, followed by, in parentheses, the department. So the department is replacing the second %S symbol. And again, we'll see how to format strings in more detail later on. So once we create this title string, what is going to happen when we call the report method? Well, we're going to print out the title. We'll print out some equal signs. And what's interesting about Python and strings, when you multiply a string by some number, it's just going to concatenate strings together. So we're going to print out a bunch of equal signs. How many equal signs are we going to print out? Well, whatever the length of, or how many characters we have in the title. So it's going to just be like a double bar, sort of title double bar. And then underneath that bar, created by these equal signs, we'll print out all of the students that are in that teacher's class. Okay, now let's consider the student class. That student class inherits from person, students or people. We're going to recreate the init method, and in addition to storing first, last, and age, meaning first name, last name, and age, to our instances of the student class, we're going to include the student's major. How do we do that? Well, we're going to borrow from the init method of person using the super function. We're going to store first name, last name, and age to our class. And then we're also going to save the student's major by using this self.attribute syntax. And again, we're requiring that anything that inherits from the person class has a report method. So let's go ahead and create a report method. And this report method is going to be different than the report method associated with the teacher class. So what are we going to print out whenever we call this method? Well, we're just going to get the info of the student, so last name, first name, and age. And in parentheses, we're going to print out the student's major. So I'm going to go ahead and run the cell. And I'm going to create some teachers, some teacher objects, and I'm going to create some student objects. So the teachers will be Stephen Hawking, age 74, department physics, and some students will be John Smith, age 20, belonging to mechanical engineering, so on and so forth. Oops, I'll go ahead and run this. And what am I going to do next? Let's go ahead and print out some info associated with these teachers and these students. I'm going to call the getInfo method, which I could do since I inherited it from the person class. So I see some names and ages of students and teachers. And let's consider, thinking back to using our isInstance function, let's try to predict what will happen when I print out whether or not teacher 1 is an instance of teacher, teacher 2 instance of teacher, and student 1 is an instance of student, 2, so on and so forth. Well, what do we expect? Well, we hope that they're all true, that teachers are in fact instances of the teacher class, and the students we created are in fact instances of the student class. But now let's consider the next cell. Is a teacher an instance of the student class? Is a student object an instance of the teacher class? And is this teacher object an instance of the person class? And is the student object an instance of the person class? So what do we think? Well, let's go ahead and run this cell. And what do we notice? Well, teachers are not students and students are not teachers. but both teachers and students are instances of the person class because they both inherited from person. Okay, I'm going to go ahead and use the add student method, which is only available to the teacher objects and not the student objects. And for teacher 1, I'm going to add student 1 and 3. And for teacher 2, I'll add student 2, 3, and 4. And once I've assigned some teachers some students, let me go ahead and print out the reports for each teacher 1, teacher 2, and for the students, or a couple students, student 1 and 2. Remember that the report method is different for teachers and students, so we expect something different to be printed out. So what does it look like for the teachers? Well, we see the report for Stephen Hawking. We have his name, his age, followed by, in parentheses, his department. And then we see, after these equal signs that we printed out, the names of his 2 students and their age. So John Smith, age 20, James Williams, age 19. And similarly, we could do the same, print out the same type of report for the second teacher. Remember, the second teacher had an extra student. So here are the students associated with this teacher. And notice if we print out the report for some students, that'll look a little bit different than the teacher reports. So what do we get? Well, for the students, we just get their name, their age, and their major. All right. So we're at the end of this lecture for today. We covered what object-oriented programming is. So remember, when we're working with objects in a programming language, we're lumping together some data and some functions or methods that we want to apply to the data in that object. So it's a way to modularize our code, which is, more readable. It's easy to add on more to our code if we sort of maintain this modularity, and just pretty much overall convenient. And in our discussion of object-oriented programming, remember we talked about the difference between classes and objects. So classes we could think of as a recipe or template for creating objects. So when we go ahead and create an object, what we're doing is we're creating an instance of a certain class. All right. Important concepts associated with classes is the idea of class inheritance. So we could have classes that are related to each other, meaning that they could share some methods or attributes in common with one another. And if that's usually the case, one is probably inheriting those attributes or methods from another class. All right. I will stop here. Office hours begins in 2 minutes. I'm going to take a quick break, and I'll come back in 2 minutes. We'll go over the coding challenge, which is just a tour of how to use the HackerRank interface and have something print out. And then I will also answer any questions that you have about today's lecture. So I'm going to go ahead and take about a 5-minute break, and I'll come back. I will go ahead and continue recording, so the office hours will be recorded. And after office hours, I will send you an email how to access these recordings, and I will update the syllabus to include a link to the recordings as well. So on that note, I'll just take a quick 5-minute break, and I'll come back. See you pretty soon.
Tina, you want a yogurt?
Right, hey everyone. I'll go over how to use HackerRank and how to submit challenges to the problems. And again, feel free to stop me at any time. Just unmute yourself if you're muted and ask away. So let me go ahead and just go to this website. So here's the Hello World problem. If I go ahead and click on it, oops. Here's what I have. I am given some background about what I'm expected to do for this problem. And so all that's asked of me is to print out the string, hello, comma, world. So you could go ahead and immediately inside the print statement, just print out the string directly. Or alternatively, you can assign the string to some variable. In this case, it's my string, and print out my string, which would also print out hello world. So in addition to giving you the problem, what's pretty handy is they'll give you the input format. In this case, you don't really need to read anything from HackerRank to do this challenge, but sometimes they will ask you to read in, well, you'll see lots of examples of this, but they'll ask you to read in some sort of data that they want you to work with. So it's good to take a look at what format you're receiving information from to solve the problem. And also something important is they tell you what format the output should be in. So it's just a string, hello world, that's print to the console. So, and here's an example. Let me go ahead and show you. You type the code inside where it says current buffer. If you notice, there's a drop-down bar where you could specify what language you want to do the problem in. And I probably should have mentioned for this course, we're working with Python 2. So you should have gotten, if you clicked on the link, it should have automatically been specified. Python 2 should have been specified. But that's something just to be aware of. Make sure that aside from the times when we're solving SQL problems, you want to be doing these challenges in Python. So here's the solution that's already written out for you. I believe before it was really, you just had an empty string, and all you're going to do is to solve the problem, you're going to say, okay, well, I want to print out the string hello world, hello, comma, world. And then if you look at the bottom underneath this console, you'll see two buttons. One is run code and another is submit code. So if you just gotta go ahead and make sure that that your code does what you expect it to do without actually submitting it for grading, you could go ahead and click run code. And what you'll notice is, okay, well, here's your output and here's the expected output. So that looks all good. And once everything looks correct, you could go ahead and submit the code, which I've already done, but I'll do it again. And in this case, there's only one test case, but you'll notice for other problems, you'll have certain test cases which you have to pass. Some of the problems are a little tricky in the case that you're expected to solve mathematical problems where there's edge cases that you might have to consider. So those edge cases might be thrown into a test case that HackerRank is checking to make sure that you've considered. So that's all there is to this. It's not as important for this problem, but you could click on this test against custom input. So if you're trying to solve some problem that takes some input, some data, and does something with it, if you want to test for certain edge cases, you don't really know what these test cases are, but say you could come up with your own, you can specify the test of custom input in this test custom input box, which you might find a little helpful later on. Okay, and as something to note, again, if you go back into our shared drive, um, as soon as send out the solutions, the reference solutions, feel free to take a look at them, although they will be right before lecture. So actually, let me think about this. I might send out the solutions a couple hours before a lecture, um, in which case, as soon as I post the solution inside of the coding challenge doc, feel free to go inside of the whiteboard doc and post your own solutions, because there's multiple ways of solving these problems, and you might come up with a far more clever way of solving a problem, and it's just interesting to talk about, see how other people went about solving the problem. So yeah, I'll post the solutions an hour before lecture. That's what I'm going to try to do. So if you have some time before lecture to take a look at it and compare it to your code, that would be great if you could share your solutions in the whiteboard. Yeah, so that's all I have to say on this problem. I'll open the floor to any questions anybody might have, either about HackerRank, about the assignments, about the course, about classes, functions, anything that we've covered today. Oops.
Hi, Dana. This is Tom. I had a couple questions.
Okay, sure.
The first one being, I'm not sure if anyone else experienced it. I'm not sure if it was because it had asked to refresh my incubator, and I think I refreshed the file. But when I was showing, and I checked in both folders for the IW classes. The first part was the same, and then it went into, like, when yours went into rectangle, my class was like point. It went on for that for a while, and then the end was like sync back up. I'm wondering if anyone else had that issue.
There was
I'm showing a different file.
If I understand the problem, was there a lag in running the cells, or was the content just different?
Yeah, it was just different in the middle portion.
Okay, so you're seeing what is? Could you send me maybe a screenshot of what it is you're seeing?
Yeah, sure, no problem.
Okay. No.
Should I do that after class, or?
Yeah, because then I'll go and check my email and try to diagnose what's going on. I also got a message that somebody has issues logging into Jupyter Hub. Is this a one case, or did other people have problems getting into Jupyter Hub? It's quite possible that this is something I copied and pasted the password wrong, so I will go check on that. But please let me know in the chat or in email if you do have issues with the login information that I sent you, and I will double check that I could get into your box. Okay.
Yeah, it looks like Linda just on the chat said that she was showing the same thing in terms of the content was slightly different in the middle.
Okay.
And then I was wondering kind of about the HackerRank. I was looking at the next problem for tomorrow, and it just seemed, I guess I'm not really understanding. And I went through the Code Academy, so that was kind of my only intro to Python. I thought I understood the class and object pretty well, but I'm just not understanding the next assignment.
Okay.
I kind of understand the input format and output format that it's wanting, but just in the way it's displayed, kind of in the buffer, like I don't really understand any of that it's displaying.
Okay, so let's. I will double check on this login information after I answer this question on classes and HackerRank. So for now, I'll come back and investigate this login information. Before I go over classes, so the assignment is just due whenever office hours is, because that's when we'll be going over the solution. But again, no worries if I know you all are busy, so if you don't get around to the assignment, that's fine. But the solutions will be sent out 1 hour before class, and then they will be discussed during office hours, so of that day. So in the coding challenge whiteboard for Tuesday, that class, that challenge called Class 1 Dealing with Complex Numbers, we will discuss the solution to that tomorrow. So let me go ahead and click on this, and I think I actually have the, let me see if I could open it up in a new window. So hopefully the, let's try, oops, I want to do it without, okay. So here, so I've added in the solutions already. So this is what you're given. Let's go over the question. So what they want you to do is they want you to write a class that creates complex number objects. And whatever you add or multiply or divide to complex numbers, it's going to be a little bit different than just adding or multiplying integers, for example. So we're going to have to rewrite over what these adding, subtraction, multiplication methods are when we create this complex number class. Okay, so we're going to be given two numbers to test whether or not we've accurately rewrote over addition, subtraction, multiplication, division, and mod correctly. So we're going to be given C and D as tests, and HackerRank is going to practice adding and subtracting C and D from each other to see if we've done it correctly. So, here's some input. Here's an example. What C might look like is going to be that first line of the sample input. So C will have a real component, which will be 2, an imaginary component, which would be 1. And D is going to have a real component 5, an imaginary component 6. So given this type of input, we're going to have to write some code that will store this information, these real and imaginary components, to our complex number class, and then access these this data, this real and imaginary attributes, and go ahead and do some computations using them. So let's take a look at what we're sort of given. Here's some sample output too. Notice that our input is going to be a little bit different than our output. While we're given complex numbers in their real and imaginary components separated by spaces, notice what we're supposed to be returning. We need to return complex numbers in a different format where we display the real component as a float with 2 decimal spaces, followed by sort of the sign of the imaginary component, which will also be a float, followed by the letter I, the lowercase I. So this is a bit of a challenge that we have to deal with. How are we going to add in our add, subtract, and multiply methods? Well, it's interesting because, and this is a little bit more complicated, and this is something that you might want to go back and read in this problem. But whenever we use the operations, the plus sign, the minus sign, and the asterisk, when we're multiplying integers in Python, integers are classes, and really what they have associated with them are these add, subtract, and multiply methods with these double underscores. And they're special because what they do is they, whenever we use the plus sign or the minus sign, we're really calling these methods underscore, underscore, add, underscore, underscore, and same for subtraction, multiplication. So we are given the skeleton of the complex class that we're trying to write. And notice that this is a new Python class, so we're inheriting from object. And what do we see? We see an init method that we're familiar with. What does it take as arguments, aside from the self object? Well, we have to, whenever we create an instance of a complex class or these complex objects, we need to provide a real and imaginary component. And inside of this init method, like we've seen sort of in lecture, we probably want to store the real and imaginary components as attributes inside of our complex class. So what are we going to do? So our object that we want to save these attributes to is called self. So inside of our init method, we might want to start by writing self dot imaginary or real. Let's start with real equals real, perhaps. And similarly, we want to store the imaginary part. So maybe a self dot imaginary. And notice, since I defined a real attribute, now that pops up in this autocomplete. So let's do this for imaginary as well. Oop. Okay, so does that part make sense?
Yes, it does. Thanks.
Okay.
Yeah, I kind of struggling when I saw the just saw everything pop out, and then like down at line 33. I don't know if that's where.
Oh, okay.
I just like expanded that and got confused.
Right. So this. Okay. I wanted to start off with the class problem, but maybe I should have gone over or assigned a different problem that just goes over. Okay, for now, we'll talk. I'll still have you do this problem because we just talked about classes, and I think it's good to just sort of solidify what we learned, sort of almost immediately. But for now, ignore this if name equals main, and we'll come back and discuss what that means. But all you really have to know is that this if statement is going to be true. So anything under this if statement is going to be executed when we submit our code. So what it's going to do is it's going to take this input from HackerRank, which is, if we recall, these two lines of integers. Each line has two integers in it, separated by a space. So it's going to read in these rows, one at a time, using the raw input function. So that raw input for, in this case, is going to read 2 and 1. And it's going to use this split method to split on white space. This is done for you, so you don't really have to worry about it, but it probably helps just to understand what's going on, to talk about what's happening in this component portion of the code. And then it's going to use this map function that takes this input, which are strings, splits them on white spaces, and converts them into floats. That's what's happening inside this map function. So the first argument is, what do you want to convert whatever's in the second argument into? Well, we want to make them into floats. So convert them from strings to floats. And, well, we're going to have two floats that are split on that white space. So we're calling the first one C. That represents our first complex number, C. Then we read in the second line by calling this raw input function again. We're splitting again on white space, and we're making those strings, those numbers, into floats using this map function. And when we talk about functions tomorrow, this asterisk notation will go over. But C has two components. It has those two integers, or two floats in this case, sorry, corresponding to the real and imaginary component of our complex numbers. So we're going to send those two floats into our complex, the arguments of our complex class. Remember, those two arguments correspond to the real and imaginary part of our numbers, and they will get saved as attributes inside of our class. So now, X and Y are going to be instances of the complex class, or complex numbers, objects. And then what we could do is, once we've created these complex numbers, X and Y, in theory, we're going to be able to add them together. We're going to be able to subtract them, multiply, divide, so on and so forth, and print out the result. So when we print, we're going to be converting the results of these operations into strings. So this is the format, the way we're going to display our answers is sort of taken care of for us. Remember, the output, we expect our complex number to be written out in a very specific way. So the real part followed by the imaginary part, followed by lowercase I, and that's taken care of for us in this string method. So this is a bit of a challenge that I've given you. Are there any more questions on this? I kind of went through it quickly, and I'll go through it again tomorrow, but does the format make sense? How you interact with the console?
Yeah, that definitely helped to clear it up, and knowing that that's the shell for it. Thanks.
Okay. Also something to note. Since we are overwriting these operations, the plus operator, the minus operator, something to note, let's take a look at the underscore add underscore method. Self is going to be the first complex number. In this case, if we wanted to add x and y together, self will correspond to the x complex number. And the second argument, no, I don't know why it's called no, is going to correspond to the second complex number that we're adding to the first. So that might be also helpful to keep in mind. So when you're creating, when you're accessing the real part of the first number, we could say that's real self. That's going to be self.real. And what is the real part of the second number? Well, that second complex number is not called self. It's an object that's called no. So if we want to add real, let's do first. Real second, that's going to be no.real. So that's also something to keep in mind. All right, are there any more questions? Okay, so for this first exercise, don't worry too much about this if statement. We'll come back to it later. Just know that what it's doing is it's reading in, using this raw input function, what HackerRank is giving to you in terms of the real and imaginary components of your complex numbers. So it's going through the process of converting them from strings to floats for you, and then going ahead and creating instances of this complex class given this input for you as well. So all you really have to worry about is editing what's inside of this class code so that you're defining how you're going to add two complex numbers together. Complex numbers in this sense being objects which have real and imaginary attributes. So one complex number is going to be self, and the other complex number is going to be whatever no is the second number. So. And you don't have to worry about the format in which you return your answer, because that's also taken care of you in this string method that was given to you. So it's going to just, when you print out your results, it'll put it in the nice format that we want complex numbers to be displayed in, using the little i's and whatnot. Are there any more questions? I'll look at creating points rather than, I will look into this conflict about the content inside of this notebook. I will get back to you on that. In the meantime, you have access to the videos, and I will take a look at your, I will go inside of your boxes or your servers and take a look at what's going on. But stay tuned to that. I will also make sure that people who cannot get into the course material, I'll double check the passwords. And if I made some mistake, I'll send you a new password. That's a great question. So when you go ahead and make changes to your Jupyter notebooks, things are auto-saved. Now, if you immediately shut down your server and exit Jupyter Hub, there's a chance that your code is not saved. So you could go ahead and save it explicitly, but it is saved periodically for you. So you don't really have to worry about saving what you've been working on. So in this case, you could just hit the save icon, the floppy disk, and that will also save it. So, okay. What about HackerRank? Oh, that's another good question. So whenever you submit challenges to HackerRank, they should still remain there when you go back and try to access them. That being said, it might not be a bad idea because I know HackerRank sometimes periodically updates their challenges, and if they do that, you might lose that information about what you wrote previously. It might not be a bad idea to copy and paste your own solutions and save them somewhere. However, we'll be sending out reference solutions that are on this link, so you will always have access to our reference solutions, and you don't have to worry about saving those as long as you have the links. That being said, you do want to save the links. So that's a good question. All right. Any more questions? All right, if there's something that I've missed, feel free to email me. You have my email address in the syllabus, and I will talk to you again tomorrow. All right, bye.